Welcome back. Now, we've said all along that statistics has these three components, and today we're going to deal for the first time with the third component, probability. So we're going to skip inference, come back to inference. Probability is our way of quantifying uncertainty. In agreement with Voltaire, we're going to try and quantify what we mean by uncertainty, and we're going to need this when we get to inference. So it's interesting that historically we got into all of this, namely into quantifying uncertainty through games of chance. And certainly life is full of uncertainty, and we don't like it very much, but we've learned to use it in games of chance. Now, initially, people use the astragalus, which has like 4 faces, and you roll those out, and games were based on which face was up, and so on and so forth. Now, unfortunately, the probability, or the chances, I can't use the word before I introduce it, the chance that any one face came up was much more likely to get some than others, and so we idealized this by introducing dice. So a die has 6 faces with a number between 1 through 6 on each, and the idea is that it's just as likely that any one face will show when you roll it as any other face. Okay, so lots of games of chance are based on this. And lastly, to simplify things even more so, how do we don't maybe play dice too often, but one thing we certainly do quite often, quite ubiquitous, and that is to flip a coin. And why do we flip a coin? Well, we flip a coin if we want to actually introduce uncertainty. There are 2 aspects of flipping a coin that are important. One is we flip it, for example, to choose who's going to serve in tennis, which side gets the sun, who gets the sun in their eyes, who gets to serve first, or in games like football, etc. Because we can't predict whether, when we flip it, a head will come up or whether a tail will come up. So one, we've got this element of uncertainty, but equally important is this notion of fairness. Okay, so equally important is that this flipping a coin is a fair way of doing things. What does that mean, fair? Because if we flip it once, it's going to come up a head, it's going to come up a tail. There's no way of telling whether, unless you've got a two-headed coin or something like that, there's no way of saying after one flip whether it was deciding whether it was fair or not. This fairness idea comes from repeated trials. If we do this over and over and over again, half the time we'll get a head, half the time we'll get a tail. So this unpredictability is for a single step. This fairness is if we do it repeatedly. So this juxtaposition between unpredictability in the short run, but quite predictable in the long run, is what makes probability fascinating and useful. And it's interesting how this whole notion of uncertainty has changed in how it's become acceptable through the years, how it's become acceptable in science, and how it didn't used to be. People used to much prefer certainty, determinism, instead of this unpredictability, this uncertainty. But now things are changing. In medicine, it's taken a while to accept this. And it's interesting because the first book on probability was actually written by a physician by the name of Girolamo Cardano, who, because of his birth situation, he was an illegitimate baby, was not accepted in the guild to practice medicine in Milano. So he turned to gambling to earn a living. And what he noticed, he was much cleverer, he was a brilliant man, he wrote about 100 books, but what he noticed were these long-run stabilities that he took advantage of, and he was able to outwit his opponents. But as I said, the problem is he wrote the first book. The problem is that it took more than 100 years for the book to get published. So it's interesting. All right. So what is probability? Now, first of all, we have to establish what we're going to use probabilities on. And our elemental entity in this theory of probability is an event. So we're going to start talking about probabilities of events. What is an event? An event is just a set of descriptions. It's a proposition. I'm just going to use it in the everyday sense of the word. So just like when you had geometry introduced to you, you had to start with a point. And then you got the line, and then you got the plane, and you built up like that. So too in probability, we start with the event. And we're going to start talking about probabilities of events. The events themselves will be denoted by capital letters, A, B, C, etc. And what we want to know about an event is whether it occurred or did not occur. Or will it occur, more properly, will it occur or will it not occur? Makes it easier if you think of the future because you're trying to predict. But you can do things retrospectively too. Okay, so that is the start of all of this. So we've got this idea that stuff is unpredictable in the short run, and it's more predictable in the long run, and it's going to converge to this probability.